If artificial intelligence can literally generate an image of a building in like a few seconds, or even create a complete architectural concept from only a few lines of text, something that used to take hours, days, sometimes weeks of work, and then if we go even further, today, there are tools that can take a simple image and turn it into this super high quality architectural render, or even transform an entire architectural space into like a full-on cinematic video experience. In a situation like this, a very serious and perhaps slightly unsettling question naturally arises. Do we still really need to spend years learning software like Rhino, Revit, V-Ray, or Lumion? Tools that, until very recently, were the foundation of every designer's workflow. And if we're honest, from the outside, it almost feels like maybe the era of these tools is coming to an end. Maybe learning them is no longer as essential as it once was. But the answer to this question is not what it seems at first glance. And the reality is far more complex and far more important than it appears. In this video, we are not only talking about artificial intelligence in architecture. I don't want to simply explain what is changing. I want to give you a very clear picture of something deeper in today's world and in the near future of architecture. Which skills are gradually losing their importance? Which skills, on the contrary, are becoming more critical and essential? And most importantly, if I were starting my journey in architecture from zero today, I will tell you exactly what I would learn faster and prioritize earlier, what I would spend less time on, and which skills I would turn into the core foundation of my professional path. This video is not just an analysis. It is meant to be a kind of mental roadmap so you can understand where you should position yourself in this major transformation. If we look back with complete honesty, until just a few years ago, the workflow of producing an architectural output was almost fixed. To create a professional architectural image, you first had to model everything, then adjust the materials, set up the lighting, and finally wait for hours for the render to finish. And that was only the rendering part. For animation, the process was even more complex. A single project could take days or even weeks before reaching a presentable output. But now, in recent years, something has fundamentally changed this entire process. Today, AI tools can take a simple image or even just a short text description and generate a complete render or even an entirely new architectural space. And going even further, some models can now transform a still image into short cinematic videos. This means something that once required a team and several days of work can now happen in just a few minutes. So the question is, if these tools have become this fast and powerful, if they can generate ideas, create images, even produce videos, is it still truly necessary to learn software like Rhino, Revit, or V-Ray? Or are we entering a phase where these skills no longer hold the same role they once did? And maybe an even more important question is this. In a world where AI is capable of producing almost everything, what exactly is the real role of an architect? I'm Hussein and welcome to my YouTube channel. In this video, I want to talk about something that many architects are currently struggling with. The question of what the role of software and architectural skills really becomes in the age of artificial intelligence. And more importantly, how we should learn not by focusing on what is going to be removed or replaced, but on what still truly matters and holds real value. Before we continue, I want to make one very honest point clear from the beginning. If I were starting my journey in architecture from zero today, my learning path would not look exactly like what it was a few years ago. For example, I would probably spend less time on things that are purely about repeating tools and much sooner move toward skills that give me more control over the design process itself. But here is the important part. This does not mean that software has become irrelevant. What has changed is something else. The way we use these tools is shifting, and that shift is what is fundamentally changing the entire learning path. But let me not open that topic just yet, because if we go into it right now, we might lose an important part of the bigger picture. Why do people think architectural software is dying? If we look at the world of architecture from the outside, it's not difficult to reach a certain impression that architectural software is becoming less important or even being phased out entirely. Why does this feeling exist? Because In recent years, the speed of creation and design has changed in an unprecedented way. Tools like ChatGPT, Midjourney, Flux, Runway, and newer AI models can now perform in seconds what used to require a full design pipeline. For example, to create an early architectural concept, you don't always need to go into heavy modeling software anymore. You can simply describe an idea in text, and within moments receive multiple visual interpretations of that concept. Or at a more advanced level, some tools can take a simple image and generate a high-quality architectural render from it. And in some cases, they are even starting to generate conceptual 3D spaces. Even in animation, what once required modeling, lighting, camera setup, and long rendering processes can now be turned into a video output with just a few simple inputs. And when we put all of this together, a very clear picture forms. If AI can design, create images, and even generate videos, then what is the role of architectural software? And if we only look at this surface level, it is completely reasonable to conclude maybe tools like Rhino, Revit, or V-Ray no longer hold the same position they used to. Maybe the future path has fundamentally changed. But here is the important point. This interpretation is mostly based on speed of output, not on an understanding of the design process itself. We are seeing change in the final output, not in the layer of decision-making, control, and real project constraints behind it. And this simple difference is what makes many people think that software is being replaced, while the reality is a bit deeper. In fact, what has changed is not the production tool, but the speed of idea generation. And this is exactly the point where we need to separate appearance from reality. If we look at this more precisely, we need to understand a very important distinction. What AI is becoming extremely good at today is generation, but what still defines architecture is control. These two concepts may sound similar on the surface, but in practice, they belong to completely different worlds. AI is extremely powerful in generation. When we say AI is strong in generation, it's not just about speed, it's about the ability to produce variety and multiple options in a very short amount of time. In the past, producing 10 different design directions meant repeating a full workflow again and again, modeling, adjusting, rendering, refining. But now, AI can generate dozens of visual directions almost instantly, each one slightly different in mood, style, composition, or spatial idea. And this is exactly where its strength lies, exploration at scale. But that is only one side of the story. The first area AI is changing is concept generation. Today, AI can produce dozens of design ideas in seconds. What once required hours of sketching or early modeling can now be generated instantly from a simple text prompt, offering multiple design directions at once. But the key point is this: these are only options, not decisions. AI can generate ideas, but selecting the right concept and turning it into a meaningful design still depends on the designer's judgment and critical thinking. The second step is mood boards. AI can quickly build the visual atmosphere of a project defining color palettes, architectural styles, lighting, and materials. What used to require manual research and careful curation can now be generated almost instantly. But again, this is only an initial feeling of the design, not a final design decision. The third step is rendering. This is where AI has created a major shift. It can take a simple model or even a rough sketch and turn it into highly polished visual outputs in seconds. But these renders are not always a true reflection of design intent. Instead, they are closer to visual interpretations of an idea, rather than execution-level documentation. The fourth stage is ideation. In this phase, AI can quickly suggest multiple possible directions. Where architects once had to manually explore alternatives, AI now works as a rapid proposal generator. However, it still does not understand which idea is actually feasible, logical, or buildable in the real world. The fifth stage is image enhancement. AI can significantly enhance raw or simple visuals, improving lighting, materials, resolution, and even applying stylistic adjustments. But this is not design correction, it is purely visual refinement. The sixth stage is animation generation. In animation, AI can generate motion from a still image. However, these movements are mostly visual interpretations, not engineered camera paths or physically grounded spatial experiences. But now let's move to the more important part: control. What truly defines architecture is not production, it is control. What does control mean? Control means the ability to manage all the decisions that eventually turn into a real building. The first aspect of control is reliable BIM modeling. In real projects, a model is not just a visual output, it is a precise database of every building component. This means every element must carry accurate information that can directly translate into construction. AI may be able to generate models, but it does not guarantee that they are buildable, accurate, or aligned with project standards. In other words, generation is not enough. What matters is control over the reliability and correctness of the model. The second aspect is clash detection. In real-world projects, different systems inevitably interfere with each other's structure, MEP systems, and architectural elements. The architect is responsible for managing these conflicts. While AI may suggest possible solutions, it still cannot fully take responsibility for resolving this level of complexity in a real project environment. The third aspect is detailed design. This is the stage where design transitions into construction. It demands precision, experience, and a deep understanding of materials and execution. At this level, AI is still not fully reliable when it comes to ensuring constructability and real-world accuracy. The fourth aspect is interdisciplinary coordination. A real project is never just architecture, it involves structure, mechanical systems, electrical systems, and multiple overlapping constraints. Managing this level of coordination requires integrating many layers of information and responsibility, something that cannot be solved through image generation or isolated outputs alone. The fifth aspect is decision-making under constraints. Every project operates within limitations: budget, time, urban regulations, and structural conditions. AI does not truly feel these constraints. It can process them, but it does not experience their real-world pressure. In the end, it is still the human designer who must balance ideas with reality and make the final decisions. The sixth aspect is turning design into buildable output. Ultimately, the most critical question in architecture is simple. Is what we designed actually buildable or not? This is where control becomes essential, ensuring that design decisions can successfully translate into real construction. If we put it simply, AI can generate ideas, but it cannot yet take responsibility for final decisions. AI is a generation system, while architecture is a system of decision-making and responsibility. And this exact difference is why the role of the architect has not disappeared, it is simply transforming. If we want to summarize everything we've said so far in one sentence, in architecture, artificial intelligence is becoming the fastest design assistant we've ever had, but it is still not the decision maker. It can generate ideas, it can propose multiple directions, it can multiply the speed of the design process, but in the end, it is still the human who must decide which idea enters reality and which one remains only an image. And here, a simple analogy makes everything clearer. AI is like a very fast intern. An intern who can produce dozens of sketches, ideas, and outputs in seconds. But no matter how fast or intelligent that intern is, they are still not responsible for the project. They don't know the project budget, they don't understand construction limitations, and they cannot take responsibility for the final outcome. That responsibility still lies with the one who has experience, professional judgment, and a real understanding of the project, the architect. And this is the key point. The question today is not whether AI will replace architects or not. The real question is who will learn how to properly use this super fast intern, and who will simply remain a spectator of its speed. Before we continue, if you've found this video useful so far, it would really help me if you like the video and subscribe to the channel. And don't forget to turn on the notification bell so you don't miss the next episodes. This simple action helps me a lot to keep creating more of this kind of content for you and to go even deeper in the next videos. Let's continue with the video. Is learning Rhino and other engineering software still valuable? After everything we've discussed, a very natural question arises. If AI can generate ideas, create images, and accelerate parts of the design process, is there still any real value in learning tools like Rhino, Revit, V-Ray, and other architectural software? These days, a common belief has formed among many architecture students that with the rise of AI, learning software is no longer necessary. But in reality, this is one of the biggest misunderstandings. Because if you don't understand design, if you don't understand modeling, and if you don't grasp the logic of a project and the structure of BIM, you won't even be able to judge whether an AI-generated output is correct or not. AI can generate outputs, but it cannot tell you which output is actually suitable for a project, which one is buildable, and which one only looks visually appealing. Imagine AI generates dozens of design options for a project. Without design knowledge, they are all just different images. But once you understand design logic, spatial structure, and real-world constraints, you can identify which idea is worth developing and which one should be discarded. That is why the real question is not whether we should learn Rhino or Revit. The real question is, how deeply should we learn these tools in the age of AI? Because software is not disappearing, its role is changing. In the past, a large part of professional value came from the ability to operate software and produce outputs. But today, the real value lies in the ability to combine architectural knowledge, software skills, and artificial intelligence together. You still need to understand modeling logic, understand project structure, and be able to control and refine outputs. But you no longer need to manually perform every repetitive task or act merely as a software operator. In today's world, learning software is less about producing outputs and more about understanding, evaluating, and guiding outputs. And this is exactly the kind of skill that AI cannot replace. Skills that are losing value versus skills that are becoming more important. If we look at it very clearly, the main shift in architecture today is not about which tools we use, but about which types of skills still hold value and which ones are gradually becoming less important. Skills that are slowly losing value, this does not mean they are completely useless, but they are no longer a competitive advantage. The first skill is repetitive and manual modeling. In the past, a large portion of an architect's time was spent building models, manually creating walls, adjusting forms, and continuously repeating design changes. Today, much of this work can be automated or even generated directly by AI. The second skill is simple and predictable rendering. Rendering alone is no longer a distinguishing skill. New tools can now produce visually acceptable outputs within seconds. As a result, simply being good at rendering is no longer the competitive advantage it once was. The third skill is basic drafting and repetitive documentation work. Parts of 2D drafting or early stage documentation that are fully rule-based and repetitive are gradually being replaced by automated or semi-automated workflows. Now, let's move on to the skills that are increasing in value. In contrast, there is another group of skills that are not only replacing the old ones, but are becoming more important and essential. The first one is parametric design. In a context where forms and ideas can be generated rapidly, the ability to define the logic behind design becomes critical. Parametric design shifts the process from manually shaping form to designing through relationships, rules, and parameters. The second skill is computational design. This is about using computational logic to solve design problems. In this approach, the architect is no longer just shaping forms, but defining the system that generates them. The third skill is BIM management. As projects become more complex and multidisciplinary, the most valuable role is the one who can manage information, models, and workflows, not just create them. The fourth skill is automation in design. This is the ability to build systems that handle repetitive tasks, whether in Rhino, Revit, or through scripting. It represents a shift from being a tool user to becoming a system designer. The fifth skill is programming and scripting. Coding allows architects to move beyond the limitations of software. Even at a basic level, Python or Grasshopper can significantly expand design capability and control. The sixth skill is AI workflow design. This is one of the most important emerging skills. It is not just about using AI, but about knowing how to integrate AI into the design process itself. The seventh skill is thinking and communication. Ultimately, the most irreplaceable skill is the ability to think clearly and communicate ideas. As tools become more advanced, the need for human decision-making becomes even more important. If we put it simply, execution-based and repetitive tasks are losing value, while system-based, decision-driven, and design-oriented skills are becoming more valuable. Future until 2030 possible scenarios. If we try to look a few years ahead, for example toward 2030, what is emerging is not just a simple shift in tools, but a deeper transformation in roles and workflows. And to understand it better, we can imagine a few possible scenarios not as exact predictions, but as directions that are already beginning to take shape. First scenario, AI becomes a full design assistant. In this scenario, almost everyone uses AI, but the difference between individuals is not whether they use AI or not, it is how they use it. In this context, everyone can generate ideas, everyone can produce renders, everyone can create fast outputs, but those who understand software, understand design, and understand the logic behind the process will consistently produce higher quality results. Second scenario, the elimination of pure operators. In this scenario, the role of people who are only execution operators becomes weaker, meaning those who only follow repetitive software commands, only model without understanding design intent, only produce outputs without making decisions. This group is the most vulnerable. But on the other hand, those who understand design, analyze problems, make design decisions will remain essential. In fact, value shifts from execution to understanding and decision making. Third scenario, full integration of AI with software. In this scenario, AI is no longer seen as a separate tool. Instead, it becomes directly integrated into architectural software, meaning instead of opening Rhino, then switching to a separate AI tool, then bringing results back, everything happens in one continuous workflow. In this case, design, generation, analysis, refinement all merge into a single environment. And in such a system, the role of humans shifts toward guiding the process, defining goals, and evaluating outputs. If we summarize all of these scenarios in one line, the future of architecture is less about manual creation and more about managing the process of creation. Now we arrive at the most important question of this video. If I were starting architecture from scratch today, considering everything we've discussed about AI and the future, what path would I actually choose? At this point, it's no longer just about software or tools, it's about the priority of learning. First of all, I would learn AI as a foundational tool, not at a superficial level, but at a level where I understand how it thinks, how it generates outputs, and where it fails. Because in the future, anyone who doesn't understand AI is essentially using a powerful tool without understanding its logic. Then Rhino, but not in the traditional sense of just manual modeling. I would learn it as a tool for understanding form, structure, and geometry. The goal is not simply to be able to model, but to understand how an idea becomes a controllable form. Then Grasshopper much more seriously than before. If I had to take one part seriously, it would be this. Because Grasshopper is not just a tool, it is a shift in the way you think. Instead of asking, how do I build this form? You start asking, what rules generate this form? And this is exactly where design moves to a higher level. Python at a practical level, not professional. You don't need to become a professional programmer, but learning Python at a practical level can fundamentally change how you think in design. Programming teaches structure. It teaches you how to break complex problems into smaller parts and turn them into executable logic, something that directly applies to architecture. In fields like parametric design, computational design, and interactive architecture, Python becomes a powerful tool, especially when combined with Rhino and Grasshopper. It allows you to automate processes, build custom tools, and go beyond the limitations of default software capabilities. In the end, Python is not just a programming language, it is a way of thinking that turns ideas into executable logic. Presentation and communication skills. At the end of the day, even the best design means nothing if it cannot be communicated properly. The ability to explain ideas, build narratives, and present design logically will become even more important than the tools themselves. That's why my focus is not only on rendering or modeling, I also try to improve presentation quality using tools like D5 Render for real-time rendering, After Effects for animation and motion graphics, and AI tools like Flux and Flow to enhance visual storytelling, especially in lighting, materials, animation, and atmospheric realism. Because in the end, what the audience sees is not just the model, but the quality of presentation and the strength of the idea being communicated. Unreal Engine. If I could go back, one of the things I would definitely learn earlier is Unreal Engine. With the advancement of AI and the saturation of single frame renders, I believe the way we present architecture is changing. A beautiful still image is no longer enough because realistic visuals are easier to produce than ever before. More creative directions will become important, like presenting architecture as a living, interactive space. With Unreal Engine, you can move beyond static images and turn a project into a real experience, where users can walk through the space, understand light and scale in real time, and form a deeper connection with the design. If I had to summarize it, today I focus less on perfect still renders and more on how architecture can be experienced, not just seen. If we put everything together, the future path of learning architecture looks more like this: learning tools plus learning design logic plus learning system thinking, not just mastering a single software. If we bring everything we've discussed in this video into one clear perspective, we can see that artificial intelligence is changing architecture, but not in the way many people assume. The real question is not whether architectural software is disappearing. The real question is how its role is devolving. Tools like Rhino, Revit, and V-Ray are not suddenly becoming irrelevant. Instead, they are shifting from being the primary goal of learning to becoming just one part of a much larger system. A system where AI generates possibilities, software executes them, and humans make the decisions. And if we look at this transformation more carefully, we realize that the real value is no longer defined by modeling speed or rendering quality alone. The real value lies in the ability to understand design problems, manage constraints, evaluate alternatives, and guide the entire design process. What is truly changing is the role of the architect. Architects are not disappearing. Their role is simply evolving from someone who mainly produces designs to someone who directs, evaluates, and shapes the decisions behind them. A final important point: the smarter our tools become, the deeper our understanding of design needs to be, not less. Because when generation becomes easy, selection becomes the real challenge. In the end, what you should take away from this video is this: artificial intelligence is not going to eliminate architects, but it is changing the definition of what it means to be an architect. In the past, value came from how well you could execute a design, but in the future, value will come from how well you can understand and guide a design. Software is still important, but it is no longer enough on its own. AI is becoming a tool that helps speed up work and expand creative thinking. In architecture, many decisions still depend on human judgment. What gets built, why it gets built, and how it takes shape are still defined by people. The role of the architect is not disappearing, it is shifting. And in this shift, those who learn how to work with AI will move forward faster than those who don't. If you found this video useful, I would really appreciate it if you leave a comment telling me what you would focus on if you were starting from zero today and what you would leave behind. And if you enjoy this kind of content, make sure to subscribe so you don't miss the next videos. Thank you for staying until the end. I'll see you in the next video.